Good morning. Today we're going to learn about using properties of exponents. So our central question today is, I can use properties of exponents. I can. So, a little bit of review from last time, some interesting things here. So, here we have example 1. We have root 7 times root 3. This is, what I'm going to do here is I'm just going to change this to a fractional power. We talked about that last time. And notice if the exponents are the same, we can multiply. And that works for any exponent. So this would be 21 to the 1/2. Or we go back in root form. Here, it's the same thing. So I'm going to rewrite this in exponent form so you can see it. Remember, 1/2 power is a square root. Again, these are the same. And when they're the same, we can divide. If they're not the same, we can't. So then we get 9 to the 1/2, which is the square root of 9, which is 3. Okay, just some things to note. So if they have the same exponent, we can actually multiply and divide them. Number 3 is a little interesting. They have a big square root. Just remember, a big square root can be broken up into 2, so we can actually break this up. Square root of 64 is 8. Square root of 16 is 4. So this becomes 2. Notice here that these are different now. These are different. So when they're different, we're going to keep the base and we're going to add the exponents. Okay? So we're going to keep the base and then add the exponents. We do that when they are different exponents. So there we go. So we're going to add 1/3 to 1/4. The issue with this is I need to make common denominators. So we have to times these. So I get 4 over 12 plus 3 over 12, which is 7 over 12, with a base 7. That's it. Not too difficult. Example 5, when we have powers like this, we multiply them. Just remember that when we multiply a fraction with a non-fraction, it just multiplies to the numerator, and we're done. So again, these are different. So instead of doing what we're normally doing, we're going to subtract. Instead of doing what we did up there. So we're going to subtract them when they're different. So we're going to get m to the 3/4 minus 9 to the 9, or minus 9/4. Denominators are the same here, so we're going to get negative exponents. Negative 6/4, which simplifies to negative 3/2. All a negative fraction means, a negative exponent, is that it's a fraction. So then once we put it in the denominator, it changes to positive. And we want positive exponents. So when we have a negative exponent, it means it should have gone in the denominator, and we can see that. If we go back to the beginning, we have 3 up here and 9 up here, so when I cancel these out, there's still 6 left on the denominator. So that's why that has to be in the denominator. Here, do you notice that these are the same? Okay, when they're the same, it'd be just like negative 2x plus 8x. And that would be 6x. So then this would be 6 root 13. Number 8, we're going to break this problem apart. So we have 3 root 27 times 3 root x to the 4th times 3 root y to the 5th times 3 root z to the 6th. Okay, And then we're going to compute these. To help us understand it, I guess, there's a couple ways to do this. The third root of 27 is 3. Here, just to help us understand it, we have x to the, 4 thirds, right? And then this would be y to the 5 thirds, and this would be z to the 6 thirds. We want to simplify or root it as much as we can. So what we're going to do is we're going to rewrite this. So we have the 3 is done, so I'm going to erase that. Here though, we have 4 thirds, so isn't 4 thirds x to the 1 and then x to the third, right? Because there's 4 thirds of them, so we have a whole x and a third that's left over. Here we have a whole y and 2 thirds that are left over, and here we have a z, 2 whole z's. Okay, so all of this has our normal numbers. So I'm going to write those out first. So we got 3x1, y1, z squared. And all of these are still fractions of a third. So we're going to take that 3, the denominator, and make it a root with an x1, y2, and those are the numerators. And that is how we do that one. A little interesting, okay? I get it. But what we need to do is we want to root it as much as we can, so we end up breaking it apart and then putting it back together. So that turned into that. All right, number 9, we want to find the perimeter and the area. That's what it says in the assignment. So this would be 2x to the 1/2, and this would be x squared. The perimeter is just adding up together. So you have 2x to the 1/2 plus 2x to the 1/2 plus x squared plus x squared. We have like terms here and here, so those are going to go together. So I'm going to get 4x to the 1/2 plus 2x squared. And we normally write them with the highest power first, so I'm going to rewrite it. And this would be the perimeter, the perimeter, and we're done. Right there. Okay. That's the perimeter. The area is a lot simpler. The area is just 2x to the 1/2 times x squared. And there's a 1 in front, so we just multiply the numbers. So this would be 2 times 1 is 2. Then we're going to add these. So it'll be 1/2 plus 2, which is 2.5, right? Except don't forget the x. The issue with that is that we got to find common denominators. So we need to multiply this one by 2. So we got 1/2 plus 4 halves, which is 5 halves. So we would write it like this, and that's the area. So this question right here is very familiar to a lot of some SAT questions that I saw recently, so that's why I have that on there. So I believe we're done. I think that's all of them. So if you have any questions while I work through these, they're pretty basic. It's just there's a lot of little rules, and so that's what makes it hard. If you have any questions about it, let me know.